Hi guys, what is up guys? It's still not 9:30, so I'll just wait for a few people to join and post out. We can start with today's video. It was a very good contest from my end. It started not that good. You can see the first question I've submitted at around 12 minutes. So I was thinking that maybe I fucked up this, but nope. It wasn't that fucked up, I think. So anyways, we can actually start. Okay, is it officially 9:30? I think it is officially 9:30, and ah, it is officially 9:30. So we can start. And close this. Close, close, close. It is not closing, not an issue. Who cares? But this thing, it makes my stream a little slower. This Leetcode thing. Okay, so let's start with today's video. Okay, the first question is, okay, I'm audible, right? I guess I'm audible. Yeah, I'm properly audible. That's great. The first question is sort integers by binary reflection. You're given an integer array nums. The binary reflection of a positive integer is defined as a number obtained by reversing the order of its binary digits, ignoring any leading zeros, and interpreting the resulting binary number as a decimal. Sort the array in ascending order based on the binary reflection of each element. If two different numbers have the same binary reflection, the smaller original number should appear first. Okay, return the resulting sorted array. So very easy. Whatever the question demands, we can do that only in brute force. Okay, because the nums dot length is 100 and 10. This is 10 to the 9. So if you make it log of 2, it becomes nothing more than 4, 8, 3, 3 trees, 9 trees. I think nothing more than 30. It's 2 to the power. It's well in the range of 2 to the power 30. So per operation you will take 30 operations, right? So per number you take 30 operations and there are 100 numbers. So n log n, that is 100 into log 2 base 100, that is somewhat okay. This is 20 and that is 100, so 20 into 100, 20, 2000, 2000 into log 100, that is to the 4 there, 16, 64, 67. So 7, 7 to the 1 4. So it's hardly like 14,000 and it's well within our limits. Okay. So we can do that. Simple. In simple terms, we can do that. Okay. So let's look at what we have done. First of all, don't focus on this top part. First of all, focus on this part where I'm making the nums. In Java, like I realized today, I don't know earlier this wasn't a problem with me, but I used to directly put comparators on integer. But now I realize that I have to convert it to primitive integer. Then only I can use the comparator based sorting. Otherwise, it was not possible. So I don't know why it is so. But anyways, doesn't matter much. So I'm making a deep copy of it of numzi. I could have made a shallow copy also, doesn't matter because ultimately we have to return nums only. I'm making a copy of it and then I'm sorting it on the basis of x is equal to binary of a, y is equal to binary of b. So if the bin is nothing but the function to get the reverse binary of a specific number. So if the reverse binary of both the numbers is same, then we have to sort it on the basis of the values of the number. If it is not same, then we have to sort it on the basis of the binary, reverse binary of that number, right? That is what the question told us. And that is what we are going to do. Now, how to find the reverse binary, that is the only challenge I think that was there. But it is also very easy. It's like temp is equal to 0. This is very simple. You can do it by yourself. Always x greater than 0. And we get the digits. And for every digit, we are going to make it like temp into 2 plus d. And xy is equal to 2. Okay. So this is the part where the reversal is occurring because instead of making d into 2, we are making it temp into 2 and plus d. And so that's it. I think that's pretty much of it. I think we don't need anything else other than this. Okay. Any doubts on this? Anything you want to ask? You can ask straight off. Otherwise, I'll just move on to the next question. Okay. 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 Let's assume that there is no question in that case, and we can go move on to the second question. The second question is largest prime from consecutive prime sum. Okay. You're given an integer n, return the largest prime number less than or equal to n that can be expressed as a sum of one or more consecutive prime numbers starting from 2. If no such number exists, return 0. A prime number is a natural number greater than 1 with only factors 1 in itself. Okay. What does it mean? You're given a value called n, okay? And from 1 to n, you have to check which is the largest prime number which can be represented as a sum of prime numbers starting from 2. So it's like 2 plus 3. Oh, is 2 a prime number? I don't think 2 is a prime number. Yeah, 2 is a prime number, sorry. Okay, 2 plus 3 plus 5 is a prime number. Then 7 and so on. Okay, so you have to find a prime number which can be represented like this. Okay, and that you have to maximize the prime number. So you have to find the maximum prime number less than equal to n which can be represented in this form. Okay, so one thing that we can see in this is a pattern. Okay, what is a pattern? You can traverse, right? So if you want to find the prime numbers, so first of all let's focus on finding the prime numbers from 1 to n. Okay, so if you're very new to CP and DSA stuff, then you won't be knowing about this algorithm called sieve of Eratosthenes. But if you have been doing CP for even a month or 2 months, or like DSA for even 2 months, you would be knowing about this concept called sieve of Eratosthenes. Okay, so I won't explain what the sieve of Eratosthenes is. It is like I'll explain a basic part of it. It tells that, let's say if you're having all the numbers like this, so a number, it is prime, then all its multiples are not prime. Okay, that is a very basic thing that we can say. So 1, 2, 3, 4, 5, 6, 7, and so on, right? We can write it like this. So 2 is prime, so we can remove 4, 6, 8, all these from prime numbers. 3 is prime, right? So we can remove 6, it is already removed. 9, 12, and so on. 5 is prime, right? So I can remove 10, 15, and so on. Okay, so that is how you can do the sieve of Eratosthenes. And finally, whatever you're remaining with is a prime number. That is very simple. So you can do the sieve of Eratosthenes with starting from 1 and ending till n. Okay, you have got it. Let's say. Now what you can do is you can traverse. Okay, you can traverse. You don't need 1 actually. This 1 is not needed. You can make it from 2 to n actually. Okay, 1 is not needed. Now that you know that that is from 2 to n, what you can do is you can have a sum. Okay, that is going to find the sum of all the numbers from the starting point. So let's say sum and other is the current. That is what is the current number that I am at currently. Okay, let's say. So sum is over here, the sum is 2, right? It was 0, now it becomes, and the current is 2. So what we have to check in to current is, have we got a sum equal to that number earlier or not? Okay, getting me? I think like if the responses are so weak now, so it's not, it's like I could have recorded videos. Okay, I can see there are people like they are watching this. So be a little responsive, guys. Even if you can see that there are 2 people, there are 3 people watching this, just be a little responsive so that I can explain things okay better. I is equal to I less than equal to. Yes, Okay, doesn't matter. I'll just keep on explaining. So I think it's okay. People are not here. I mean, I can see there. See, if you want, I can show you that there are 6 people watching it. I don't know if you can see it or not. Okay. Just don't look at the ad. There are 6 people watching it. Okay. So I expect people to be a little responsive. If you can't even, okay, so I'll just tell you one thing. I'll just put a poll. I don't know whether you guys are able to comment or not. So I'm putting a poll. So if you guys are not able to comment, so I'll tell you one thing, that you can subscribe my channel, because I usually stream on subscribers only mode. So yeah, that's it. Okay, sum is equal to current is equal to. So we have, rather let's say sum is equal to current is equal to. So earlier, before this, have we encountered any value as 2? No. Then we go to 3. And what does sum become? Sum becomes 2 plus 3, that is 5. Earlier, nope. Now we come to 5. Okay. What is the sum? 10. Sorry, I'm making the different. Yeah, I'm correct. So 5, right? Have we got 5 earlier? Yeah, we have got 5 earlier in this position, right? So 5 is a possible number. By default, 2 is a possible number, remember. That is the reason we are not checking for 2. So 5 is a possible number, correct? Then go to 7, okay? 7, no, it is not there. So that is 17, okay? And post 7, it comes as 8, 9, 10, 11. 11, okay? 11, have we got 11? Nope. So we can do this checking and so on, okay? So if you want the code, I'll just show you how the code looks like. Dude, even on the poll, there are no comments. I think, did I disable anything? Like, you guys can see the poll. I can see the poll, man. I don't know what's happening. But anyway, it's not an issue. I'll just remove the poll for now. And yeah. So look how the code looks like. You have to find the largest prime. So if n is equal to 1, return 0. You know that we don't need to do anything because n is not a prime number. Sorry, 1 is not a prime number. So n is equal to 1, return 0. We're done with it. Otherwise, we can make a hello. Hi Pradeep. Hi. So otherwise, what we can do is we can have. I solved all 4 today. I'm going to explain all 4 of them. I'm currently at the second question. Okay. So this part is nothing but this is the Siva-Paratostenes part. Okay. I'm taking a boolean as prime. I'm filling it with true. That is all the elements are prime for me initially, and 0 and 1 is false because 0 is not a prime number, 1 is not a prime number. Then p is equal to 2 to p into p less than equal to n. That is, I'm going to traverse till square root of n. Okay, because if you traverse till square root of n, so the next multiple of it. Okay, because I have already covered. Let's say why do I do this? Or rather, I think it's better to not explain because Siva-Paratostenes is a very simple thing that you will also find out anywhere on the internet. Okay, I won't explain that then. Then this is basically the Siva-Paratostenes part. After that, what we are doing is, okay, this is basically nothing. Okay, this was, I was thinking of something else, but I don't think this was needed. Yeah, this was not needed. Okay, so long sum is equal to 0, and then I'm getting a map or set, whatever you may call it. I like to I prefer calling it map, no matter is a set or anything else. Okay, even I prefer calling any 2D map, 2D array as DP, whether it's a dynamic programming thing or not. Okay, I prefer doing that because it gives me like my muscle memory clicks on. Okay, so answer is equal to 2 because like even in the default scenario, 2 was only thing which was there in the sum as well as in this. Okay, so both of them will have. So answer is by default 2. Then I'm traversing from 2 to all the numbers, and if I find that any number is prime, then what I can do is I can check if that number has been there in the map or not. What the map consists of? It consists of all the sums, all the possible sums. So if it is there in the sum, then answer is equal to I. Okay. Otherwise, not an issue. We can continue doing it, and no matter what, sum plus is equal to I, because sum is the summation of all the prime numbers starting from 2. So sum is plus is equal to I, and map dot add sum. So I can add sum to map to the set rather. Okay, and at the end we can return answer. Okay, any doubt on this? I don't think this is that problematic. But still, if you guys have any doubt on this, you guys can see. Okay, not an issue. I'll just consider it as a no. I'll move on to the next question. The third question is total score of dungeon runs. You're given a positive integer HP and two positive one indexed integer arrays damage and requirement. One index, it doesn't matter, it can be zero indexed also. There is a dungeon with n traps, room number from 1 to n. Entering room I reduces your health by damage of I. After that reduction, if your remaining healths are at least requirements of I, you earn 1 point for that room. Let score of J be the number of points you get if you start with HP health points and enter the rooms J till J plus 1 dot till n. Okay, in this order. Return the integer, score 1, score 2. So we have to find the summation of all the scores. The sum of all the scores over all the starting rooms. You cannot skip rooms. You can finish your journey even if your health points become non-positive. Okay. You can finish your journey even if your health point becomes non-positive. Okay. This is a nice one. You can finish your journey. Okay. So, like I just consider that this part I just considered that it is there, but this is a nice question. That's a nice point. Like if this condition was there, then this question would have been not a medium question. This would have been a hard question. Okay. I didn't notice it during the contest, but yeah, that's good. So what is basically told to us in the question is that you're given an array, okay, called damage, and you're also given an array called requirements. So let's frame the question like this. I wasn't able to solve, but was thinking in terms of prefix sum. Yeah, you're right. It was a prefix sum and a binary search on that. This is one of my favorite genre of CP questions or DSA questions where you use you use prefix sum and binary search. Very good question. Okay. See, over here it is telling that I solve all four of them. Okay, I'll be explaining the fourth one also post this. So let's say if you're starting at one position, okay, and then your health goes on reducing one by one, okay. So on every cell, we check if that health that you're having, if it is greater than equal to the requirement of that cell, then you'll get a score of 1. Okay. Otherwise you won't get a score. Okay. But we can frame the question like this, that since we have to find the summation of all the scores, so let's frame the question like this, that I am currently at this cell. Okay. So from which cell can I start so that this cell is going to contribute to the score? Okay, you getting it? What I'm trying to convey? From which cell do you need to start so that you can get this score? Okay, because let's say this is having a damage of 1, this is having a damage of 2, this is having a damage of 3, and this is the damage of d4. Okay. Now if you want to start from this cell, that means HP minus d2 plus d3 plus d4. Okay. This value, the value that this is going to yield, it should be greater than equal to the requirement of that cell. Okay. Correct. Now see one thing. If I start from d3, so earlier I was subtracting d2. Now I will start from d3, right? So it is already possible, right? If I start from this cell and I can reach till this cell with getting the requirement with getting the whole health greater than equal to requirement, then if I start from this cell, then also it is possible. If I start from this cell, then also it is possible. Okay. So if I can get the farthest cell that I can start from, so that this condition is satisfied, so all the cells in between I can start from that, and that will contribute to the score for that specific cell. Okay, this was the observation that you needed to make. Now this d1, d2, d3, this summation, how can you find out? You can get a prefix sum, which I think, I don't know your name, SHPI5AG, so which he was saying, correct, basically. Okay, so that is what you have to do for this part. Okay, and the HP part is constant, and for every cell the requirement is also constant. So for how many, what is the complexity that you can compute this in? It is big O n, right? But this part, how would you know which to take, from which cell to start? So just in order to say which cell to start, you have to do binary search. Okay, why you have to do binary search? Let's say you're having these cells. Okay, and first of all mid is over here. So if you start from this cell, then you can meet the requirement. Okay, then what we have to do is you have to be a little bit greedy. Let's start from a cell before this. Okay, you became greedy and you failed. Okay, so this part you can't start from here. So now you will start from the one in middle. Let's check this. Okay, you can do this. Then again go over here. Check this. Oh, you can't do that. Then you check over here. Yeah, you can do this. So this is the farthest point, right? And this thing, it is the binary search part. Okay, clear? Any doubt? Okay, so HP plus D2, D3, D4, so this thing, it should be greater than equal to requirement. Okay. If this condition satisfies, then you can go farther left. Not clear. Which part is not clear? Oh, okay. Did you say no doubt? I'll just consider that. Okay, I'll just continue. If you find that there is no doubt, write no doubt. If you think it is clear, so that write clear. Okay. So whatever it is, just be a little bit more expressive. I'm low of words. I'm losing words. My vocab is going down. No doubt. Great. Okay. So this is the binary search part. Okay. Now let's think of it like this. So now we got the answer, right? So now I'll tell you that let's dive a little bit into the code. Okay, and try to understand what I'm trying to say. This is something that I think it was not needed, so I just removed it. Because I was starting from I is equal to 1, just in order to consider that, okay, I don't need to calculate log n for the first one, but it is very simple, so it's basically nothing else. So I'm making a prefix sum where I'm getting the prefix sum of all the damage values, okay? Nothing else. Then score is equal to initially 0. I'm traversing L is equal to 0, R is equal to I. position is equal to -1. That is the farthest position that I can have. That is -1. -1 means that it is not reachable. Okay. While L is less than equal to R and mid is equal to L plus R by 2, this is basically a expression of L plus R by 2 which doesn't gets overflown. Okay. Then S1 is equal to prefix of I and S2 is equal to prefix of mid minus 1. Okay. And it is 0 if mid minus 1 is less than 0. Okay, so we can't have that, so then in that case we make it 0. So we get the prefix of all the damages, the prefix sum of all the, I'm sorry, we get the sum of all the damages between mid and I, right? Between mid and I, we get the sum. We get it. What is the starting health that we can have? It is requirement of I plus S1 minus S2. This S1 minus S2 is the damage. Okay. See, I just told you that HP minus this is greater than equal to requirement, which means HP is greater than equal to requirement minus D1 minus D2 dot dot dot. Correct? This is the part that I'm trying to convey. So this thing, this start, it should be less than equal to HP because HP should be greater than equal to that point. So if start is less than equal to HP, then position is equal to mid. That is, yeah, we got a position, we got a valid position. But we are greedy, right? We are greedy. So we will try to make it left. We will try to make R is equal to mid minus 1. We will go left. But if we are not successful in that, then L is equal to mid plus 1. So this is basically the binary search part. And if position not equal to minus 1, that is, if it is reachable, then score plus is equal to I minus position plus 1. Okay, that is the number of elements in between I and position, including both of them. And then we can return score. Any doubt on this? Anything that you want to ask? If there is no doubt, you can write no doubt. Okay. If you want me to move on to D, I can move on to D. If there is no doubt, I can move on to D basically. Yeah, okay, no doubt. Okay, let's move on to the last question. The question, the most awaited question, I guess. The fourth question is maximum subgraph score in a tree. You're given an undirected tree with n nodes numbered from 0 to n minus 1. It is represented by a 2D integer array edges of length n minus 1, where edges of I is equal to a of I, b of I. Indicates that there is an edge between nodes a of I and b of I in the tree. You are also given an integer array good of length n, where good of I is 1 if the ith node is good or 0 if it is bad. Define the score of a subgraph as the number of good nodes minus the number of bad nodes in that subgraph. For each node I, find the maximum possible score among all the connected subgraphs that contain node I. Return an array of n integers where ith element of is the maximum score of node I. A subgraph is a graph. You know what a subgraph is. You know what is a connected subgraph is. Okay. What does this question tell us? Let's take this. Was both first children subgraph and then parents other children? Was both first children subgraph and then parents other children? Hmm, I don't get it. I have copied something. I don't know. No, not getting copied. One drag and drop. Okay, not an issue. So 1 0 2 3 4. 1 0 2 3 4. 0 2. So 1 0 2 3 4 where okay was both. Okay, never mind. So this is bad. This is bad. This is good. This is good, and this is good. Okay. So if you check this 0, okay, and if you consider the subgraph of this, so this is the maximum that you can get the score from, because the score of this is 3 minus 1. Okay. If you consider 2, it's the same thing. Okay. You have to consider this. Right. Well, in 2, you can't consider this. Okay, because that will lead to the score of minus 1. It is not good. You can't even consider this, the whole tree. You can't even consider this because that will also make the score 1, which is not the most optimal. But this 2 is the most optimal. Okay, that is 3 minus 1, that is 2. Okay, so that's it. So for 1, it is 3. For 3, also it is 3. For 4, it is also 3. Okay, so you have to consider that, considering that node to be a part of a subtree or subgraph, whatever you may call it, um, what is the maximum score that you can get, and what is the score? Score is nothing but the sum of good minus sum of bad. Okay. So one thing, if you notice this kind of question, one simple thing that you can always take into consideration is that for good you can add 1, for bad you can subtract 1. Correct? Then only you get the answer. This is very much clear. But how do you get this? Because it is not very simple. Okay, first of all, you don't know where the starting point is. You don't know that this starts from here. You can also start from here, right? Sorry, uh, not this color. It can also start from here, right? Usually you started from 0 only, right? So the moment you start from 0, you can you can't check like this and this. Okay, you can't check directly like this. So you need a recursive approach, right? So first let us look into what was the value of n. It is 10 to the power 5. Okay. So whenever you see that there is 10 to the power 5 or somewhat like that, so it's basically a DFS BFS question. You're well and good enough to go with it. Okay. So you start from 0, very similar to what Pradeep was telling. That is, if you're going to start from 0 and if you add 1, so you have to consider like 0. What is there above 0? Is there anything above 0? No, nothing is there. But what are the components that are connected to 0? Only 1 is there, right? So whatever the score of 1 is, it will be there along with minus 1 from the 0. Correct? How do we find the score of 1? The score of 1 minus 1. This minus 1 is from 0. Score of 1 is nothing but the maximum of score of 2 and 3, correct, plus 1. So score of 2 comma 3, the maximum of them, plus 1. What is the score of 2? The score of 2 is nothing but minus 1 plus the score of 1, right? Plus the score of 1, but the one on top of it. But you haven't calculated 1 on top of it. It's a circular dependency, right? So first of all, you have to consider that let's not think about getting the score. Let's think about that we can only go downwards, not upwards. Okay, later on we'll go upwards. So for now, we can say the score of 2 is minus 1. Why didn't you consider node 0? Yeah, that is what I was explaining. Okay, for now we are going to go only downwards, not upwards. You're right, you're right. 0 in this, you can go like this, correct. But I'm now only considering that first of all, I'll just consider the downwards. So what is, for 3, what is it? It is score of 4 plus 1. And what is the score? It is 1. Right? So now let's make the downward scores. Okay. This is 2. This is 3. And this is 2. Okay. So 2, 3, I'll just erase this so that it doesn't make you confused. So this part we are done, right? Now we have to traverse the opposite way. How to do that? So you are at 0. So 0 is 2. Okay, because there is nothing on top of it. Correct? But since you got the 2, okay, since you got the 2, now what you can do is whenever you're going to the next position, you can reverse it. It was earlier minus 1, right? So you have to add that to it. That is 3. Okay? So you can reverse it. क्यों भाई, क्या हो गया भाई, थंबनेल गड़बड़ है क्या कुछ? कर सकते हैं भाई, टाइम नहीं मिलता मुझे, मन नहीं। अच्छा, थंबनेल पे वो डाल दिया क्या मैंने प्रीवियस कॉन्टेस्ट का? नया कॉन्टेस्ट नहीं डाला ना? करेक्ट करेक्ट करेक्ट, सही बोल रहा हूँ, करता हूँ मैं चेंज। अरे आज ये हो गया ना, आज मैं सोच रहा था वो, ये होता है ना भाई, तुम जब एक हफ्ते बाद आते हो वापस कोड करने तो तुम्हारे दिमाग से सब कुछ चीजें उड़ जाता है। तुम दिमाग में नहीं रहता कि भाई ये, हाँ करेक्ट कर 477 है, तो वो उड़ जाता है कि भाई सीक्वेंशियली तुमको वो याद नहीं होता है चीजें। जैसे मैं कभी कभी देखना, ये जो है ना, ये फॉर एनी डाउट, ये डिस्कॉर्ड और इंस्टा वाला लिंक, ये भी मैं कभी कभी देना भूल जाता हूँ, ठीक है। एंड में जाकर मुझे याद आता है कि हाँ भाई ये तो देना भूल गया मैं। बहुत सारी चीजें होते हैं। So now you have to go traverse downwards. Okay. So you traverse like this. So अभी क्या है ना? So now it is going to be -1 for this. So this 3, what you can consider is 3. It can go like over here. It can go over here. But this you have already considered, right? Now you have to consider the top one. ठीक है, बट टॉप 1 तो मुझे कोई बेनिफिट नहीं दे रहा, करेक्ट। टॉप 1 क्या होगा ना? टॉप 1 इज नथिंग बट -1 एंड दिस इज 1, so 1 minus 1, that is 0, so I won't take it. Okay, I won't take it. Sorry, my mistake. This is 3, so 3 minus 1, so I won't take it. अभी मैं चला गया इस पे, अभी मैं नीचे आऊंगा 2 पे, ठीक है। सी दिस 2 पे हूं मैं, so this is 3, so अभी इसके ऊपर क्या है 3, so 3 minus 1 is 2 and already value क्या है इसका -1, ज्यादा कौन सा है 2, so I'll consider 2. Okay, now I'm at this position 2, I'll consider the one on top of it 3, correct, और ये 2 है तो 2 plus 1 3 है, no matter, ये 1 है, sorry क्या बोल रहा हूं मैं, 2 plus 1 3 है तो obviously 3 है ना, तो ये ज्यादा बढ़ जाएगा। Okay, so now this becomes 3. Okay, अब ये जो है, ठीक है, this is 1, इसके ऊपर क्या है 3 और ये क्या है 1, so ये जो 3 है और ये जो 2 था इसका पहले का जो 2 था, ये 2 + 1 होगा तो ये भी 3 बन जाएगा। ठीक है, आई थिंक इट इज गेटिंग अ लिटिल बिट कॉम्प्लेक्स फॉर यू टू अंडरस्टैंड। आई जस्ट गो डायरेक्टली टू द कोड because second wala, like downward part it was easy, but the upward part it is a little bit difficult to handle without the code. Okay, see, I'm making a graph out of it. Good is good, n is n. I'm getting the values out of it. D is nothing but the downward. Okay, and answer is the basically answer that I'm going to return. D is the downward. I'm making a DFS1, that is for downward. DFS2 is for upward. It doesn't mean that I'm traversing upwards. I'm traversing downward only. But I'm going to consider the one on top of it. Okay. So DFS से ये तो हो गया कि भाई अगर आंसर -1 होगा, लेकिन अगर गुड होगा तो 1 होगा, अगर नहीं होगा तो -1 होगा. You know this. Then for all the neighbors of it, if it has already been visited, that is previous thing, this is already visited, then you don't have to do anything, you can continue. Otherwise you have to visit the next part, that is VUD. Okay, and you go on doing it. What is the answer? Answer is if D of V, that is the downward of the next element, okay, if it is a positive number, okay, whatever you got, if it is positive, yeah, one more thing, I forgot to mention over here. So this -1, this all these things, now you're going to, let's say over here, this thing, these two were also red, okay, these two were also red. So this would be -2, right? And this would be -1. So this would be 1, right? 1 plus the maximum of, as I told you, what is the formula for this? It is score of 2, 3 plus 1, right? But I made a mistake over here. It's not score of 2 plus. How you know the above one doesn't have score from current node subgraph only or not? How do you know the above one doesn't have score from the current node subgraph only or not? थोड़ा language समझ में नहीं आ रहा मुझे. But anyways, I think if I explain it to you, you'll get to understand. Okay. Otherwise, you can take the doubts at the end. Okay, doesn't matter. तो मैंने बोला score of 2, 3 plus 1, but this is wrong because अभी अगर score of 2, 3 मैं ले लूँ ना तो -1 और -2 है, तो that will make it -1 plus 1, that is 0. But मैं क्यों लूँगा भाई? I can keep it single-handedly also, right? So this I will only take if it is greater than 0. Sorry, this one. Okay, this I'll only take if it is greater than 0. If it is greater than 0, then only I'll take dv, otherwise I'll make it 0. Okay. Sorry. I made another mistake. मैं मैक्सिमम सोच रहा था ना, नहीं सॉरी, माय मिस्टेक, ये तो मेरा गलती है. भाई ज्यादा मत बोलो भाई. तो देखो, so this DFS is very simple. We are going to add all its children, the dv value of all its children to it. Take all its child to it. Correct? And du is equal to answer. So d of u is basically nothing but sum of all the dv's. Okay, क्योंकि ऐसा नहीं है ना कि मैं बस ऐसे ही जा सकता हूँ. I can go like this also. I can consider both of them also. So it is not score of 2, 3. It's not maximum of 2, 3. It is all the scores. Score of 2 plus score of 3 plus score of plus और कोई score नहीं है, plus 1. ठीक है, score of 2 plus score of 3 and like this. आज 4 क्वेश्चन बने. Okay, so you can take all of them, but you will only take them if it is greater than 0. Okay, I'll explain with that situation only. Don't need to worry. Okay, you got it. Now look into the upward one, upward DFS. Okay, the DFS is downward only, but I'm going to consider the upward part. Result is nothing but d of u, that is the score that I got towards the down, plus maximum of 0, val. Val is nothing but the score that I will get from top of it. Okay, because that is something that I can't recursively. That was a circular dependency, right? But since I have calculated all of them, I can get the circular dependency. I can remove the circular dependency now. Okay, so max 0, val. The value, this val is initially 0. Okay, it should be initially 0. Yeah, it is initially 0. But post that it becomes, see what the value of val becomes, it is result minus mat dot max 0 comma d comma v, d of v. Okay, that is whatever this part is. See, how can I get the value of this? Let's say I want the value of this, right? For this, what I can do is I can consider this and this. I'll use a different color. I can consider this and this, right? But I have already considered this, but this I was not being able to consider. But how can I get it? The value of all of them minus the value of this. Correct? So you get it. You get it, right? So you can do this. Let's do this question again. And now it would be easier for you to understand what I was trying to say. 0, 1, 2. I'm rewriting it as like this, okay? Because I'm starting the root from 0. It doesn't matter, you can start from any number that you feel like. 4. So let's, okay, so 1 is green, 3 is green, 4 is green, 0 is red, 2 is red. Red means bad, okay. Let's do first of all, let's do the d of u. Okay. What is the d of this? It is d of 1 minus 1. What is the d of this? It is d of 2 plus d of 3 plus 1. Plus 1 because it is green. This is minus 1 directly. Okay. This is d of 4 plus 1. Correct? And this is 1. Now let us rewrite them. D of 4 plus 1 is 2, right? I can write it as 2. D of 2 plus 3 plus 1. Now see one thing, I just told you that I am only going to consider the positive ones. So this 2 is not positive, so I won't consider them. So it becomes 2 of d of 3 plus 1. That is 3. Okay. And this is d of 1 minus 1. That is 3 minus 1. This is 2. Okay. You got the downward traversal. Very simple. Now let's get the upward traversal. So for every possible, so look into this code, okay? Result is equal to d of u plus mat dot max 0 comma val. This is just to consider that if it is negative, though you don't consider that. So initially result is nothing but d of u plus mat dot max 0 because it is value is 0, okay? So initially it is 2. So we got the answer. This is the final answer, okay? Whatever is the final answer, I'll just mark it as like this. You got the final answer. For 3, now what is the value of val now? It is result, okay, result minus mat dot max d of v. That is 2 minus 3. Okay, 2 minus d of v, that is 3, that is minus 1. So the value is minus 1. But I just told you are going to consider only this if it is greater than 0. Okay, so you are not going to consider that. So 3 is also final answer over here. Now since 3 is the final answer, you can go over here. It is nothing but 3 minus 2, that is 1. Right? 3 minus 2, that is 1. That is the upward part. That is the maximum that I can get on the top of it. So 2 plus 1, that is 3. So now this becomes 3. Okay? And what the result becomes now? It is 3 minus value. What was value? Sorry, my mistake. Yeah, 3 minus d of v. That is 3 minus 1. That is 2. Okay? Value minus result minus this. So 2. So 1 plus 2, it is 3. So we get the answer, right? So it is 3. We also get this. We are left with this, right? So let's try to understand what the value of this would be. This is minus 1. This is 3. Okay. What is the value? The value is top minus 1. Correct? But remember one thing. It is result minus mat.max 0 comma dv. So if it is negative, you won't consider that. Okay. So it becomes 3 only. So this becomes 3. And 3 plus minus 1 is 2. Okay. Which is maximum? 2 or minus 1? 2 is maximum. So this becomes 2. And 2 is the final answer. If you look at the solution, it is going to be 2, 3, 2, 3, 3. Look at the solution. It is 2, 3, 2, 3, 3. Okay. So any doubt on this? Anything that you want to clarify, like why is this happening like that? Or actually, I will tell you that if you got the basic idea of the workflow, um, it's more than enough for you, because this idea, this, see, the downward traversal, it will be easy for you to understand, but the upward traversal, I'll just explain it to you in the most simplest way. That is, result is equal to d of u plus mat.max 0 comma val. Val is nothing but the contribution of the parent. Okay, val is nothing but the contribution of the parent, and d of u is the downward, that is the contribution of all its children. So contribution of children plus the contribution of the parent. Okay, so you get all the corresponding ones. For every specific value, I'm going to make it result minus mat.max 0 comma d. Why? Because result, that is the contribution of the whole thing, of the whole graph, whole subgraph that it is going to consider, minus d of v. I knew it was downward plus upward in second traversal, but couldn't think of how to do the upward one. Yeah, great. So on the upward part, you have to remove the dv from it. Okay, that is the downward part. Whatever is the answer, see, whatever is the answer, okay, let's say whatever is the answer, branches these are, okay, you got the answer, but let's say if you are at this position, okay, the d of v is nothing but the answer from here, and result is nothing but the answer from here, the answer of I. So if you want this contribution, you can subtract them. It is very similar to the prefix logic, so you can subtract them. Okay, I hope this makes it pretty much clear. I think this is the best explanation that I could come up with. If you still don't understand it, so I think I'll just tell you that please go through the video once again. You will be able to understand. Okay. So yeah, let's move on to the rating of the problems quickly. जल्दी जल्दी करेंगे भाई, अब तो जल्दी जल्दी हो जाएगा. मजा आया आज का कॉन्टेस्ट? बताओ पहले. फर्स्ट थिंग, did you guys like today's contest? It was a good contest, I think. The questions were like good. This is like once in a lifetime type of contest. I'm too much exaggerating it, but yeah, it is like it's a very good contest. I think questions like this should be there. Should be there. It should be normalized. Easy, hard. I think this was in some Uber way. This type of question. Maybe, I don't know. So the first question, it was easy, man. No. Sorry, my mistake. The first question was sort integer. So yeah, it was. I won't consider it as that easy, because comparator based things. But yeah, it is on the easier end, but not as easy as the first questions are usually in Leetcode. Okay. The second question was largest prime. You needed a little bit of brain on that. Yeah, correct. So first question, like I think even I was checking, my ranking was quite good. So I also thought that I have messed up the first question, but I saw that there were people who have done it with, like, if look at this, if someone is at the position of 7th and he has done the first question in 3 minutes 10 seconds, the second question in 3 minutes 59 seconds, what the heck is wrong with this guy, man? Okay, so but still I think the first question was a quite tricky one. The moment I refresh this now, you'll see that the ranking has gone drastically changed, because there are so many people who are currently getting plagiarized. Correct, correct, correct. So there are so many people who are getting plagiarized. I'm really amazed to see that. I don't know why are people doing like this. You know what? Like this gets down the moral of people like us. So, anyways, doesn't matter. So the second question was largest crime. This one was also on the medium part. I'll keep it on the this part only. The third question was the binary search one. Now, yeah, this needed a little bit of brain on that. So this will be on C like this, and the last question will also be like this. Or should I make it hard? Because it needed upward and downward. Yeah, I think yeah, it demands hard. It's okay. Downward, upward, along with a prefix thing that you have to come up with. Third one was easy. Yeah, third one was easy actually. Yeah, actually it was easy, but I think you're right. Let's rate it and over here. It was easier. And if I rate it over here, then I can rate this D over here. And now it makes sense. Now it makes better sense. So A B C D. That's a rating. That's pretty much a rating. Third one was not that easy, but yeah, you have to come up with binary search and prefix thing. So medium. That's it from my end, guys. So I think if you know how to do upward, then you can. Else, it is difficult. Yeah, like I just thought of this. Like during the contest only, I've thought of this. This is very similar to a question that I've come up across. That is the advanced form of the diameter of a tree. Okay. So yeah, you can consider that I knew a little bit of upward, but it was not upward completely, the diameter. But an advanced version of diameter was there, which was a complex one. So yeah, you're right. Okay guys, so that's it from my end. Thank you guys for joining. I'll meet you on next Sunday with another contest, and yeah, I need to change my what to say, thumbnail. I'll just change that. Okay, that's it from my side. Thank you guys. Bye.